It takes so little of these chemicals to have an effect. The current EPA guideline is 70 nanograms per liter. That is a tablespoon of salt in an Olympic swimming pool. I mean, it's nothing, but yet it is enough to cause health effects down the road. And some of the states have moved towards much lower, as in so maybe 10 nanograms per liter, so quite a bit less. EPA has been slow to set enforceable standards, and even right now there is no enforceable drinking water standard. There's just an advisory by EPA. So several states have decided to take matters in their own hands and set drinking water levels that protect their citizens, and those concentrations, maximum contaminant levels, are below what EPA is currently suggesting. New Jersey has been the first to implement that. Maine, Vermont, New Hampshire are all working on it. Massachusetts has pledged to develop their own set of contaminant levels that can be allowed within the state. So some states move ahead. Rhode Island has decided not to do that and wait for EPA to act. If several of the New England states are moving ahead and your own state is not, then it looks like it's being left behind. So it could be that in a couple of years that certain drinking water would be considered unsafe in Massachusetts, but the same drinking water crosses into Rhode Island and you can still drink it. I think actions is both what you can do as an individual in your home to protect yourself and your family, and obviously we discussed some of these possibilities. The other part is, of course, you should reach out to your state or federal congressional delegation, the EPA or the DEM, to voice a concern and make sure that these chemicals are more effectively regulated. That's really the only thing you can do to prevent further exposure. Something has to change in which chemicals we're allowed to use in the country. I think anything that passes the forever test is, then we shouldn't produce these chemicals, unless there's a real important need. The question is just, where are these compounds really necessary and we have no adequate replacement? I think for a while the idea was that aqueous film-forming foam has to be fluorinated to be effective, and by now there's substitutes that seem to be working just as well. So that's one of these cases where you say, we need these foams because they're really important to protect human lives, but actually that it doesn't always have to be fluorinated. Educate yourself, and then of course take sensible steps to limit the most likely exposure sources that you can deal with yourself. Ideally, of course, this is regulated a little above us at EPA level. EPA has the tools to say certain chemicals shouldn't be produced because they aren't safe. That would be the easiest. Make sure your drinking water is fine. Most major suppliers, that should be a given at this point. If you're in a private well, ask your local health department whether in your region there's occurrence of these chemicals known. If there's nothing, then you're probably fine, but otherwise you can go and have it tested. If you go to the URI STEEP website, then you can find some more tips and sheets of what you can do. uri.edu/STEEP. There you go.